have been kind of feeling a little bit overwhelmed when it comes to modeling. I'm going to level with you. Modeling is probably one of the hardest disciplines in 3D to master. But in this video, I'm going to share with you one very good, let's just say it's almost like a life hack, like the game genie for 3D modeling. And that life hack is called volume modeling. Now, volume modeling might sound like a very technical term, but it's actually a very easy concept. What it allows you to do is model with basic shapes. So you can have basic shapes, you can merge them together, you can subtract objects from one another, doing kind of Boolean commands. And what it allows you to do is generate very complex looking pieces of geometry from very simple pieces of geometry. So enough blabbing, let me just show you how this whole workflow, this volume modeling workflow works. Right, so here I have an example of how we can use volume modeling workflows to create a directional gamepad here. Now, modeling something like this, even I don't quite even know how to do it the right way, but that doesn't matter because I'm going to show you the alternate way of modeling something like this. Okay, so let me just break down the scene for you. I have a few extrudes that were made from an end side. You can see I'm just extruding those things, group them together. And this is very important because if I group objects together, I can add or subtract all of these objects to these other cubes below. So I got two cube objects here that make up the main parts of the directional pad. And what I basically need to do is subtract these arrows from these two cubes. So how do I do that? Well, I'm going to use that volume modeling workflow that I mentioned. And you can find all of those tools in this menu right here. So if I click and hold, you can see there's a volume builder and there's a volume mesher. So what we're going to do is we're going to build a volume and then we're going to mesh that volume second. Okay, so let's build the volume. What the heck is a volume? What I'm going to do, as you can see, nothing happens. It's a generator object, so I need to feed objects into this generator object for it to generate new information off of it. So if I go and click and drag to get a rectangular selection, select all of these objects here and place them as a child of the volume builder here, you're going to see, oh wow, that's great. This is really a fast way to model something complex. No, we're seeing all these little squares here. And if I kind of orbit around here, you can see they're always facing towards the camera. So what is going on here? Well, our volume builder just took all of the geometry we fed into it, which you can see in this little list down here. It's kind of like showing you, Photoshop layers of what objects are in here. And right now it's using the union mode. Okay, so it's almost like Pathfinder. You can union things together, you can subtract, all that kind of stuff. And you can see that this is generating voxels. Now you might be wondering, what is a voxel? It's a very simple concept. Voxels are basically 3D pixels. Okay, so right now our voxels are very large and you can see that the size of our voxels is 10 centimeters. So what we need to do to get our form back is actually just lower this voxel size. So if I bring this to say 1, and here you can see we're getting our form back. And so basically what we're doing is we're adding more pixel density by lowering the voxel size. And whenever you up the resolution, you're upping the pixel density or voxel density. So that's exactly what we're doing here. So I can even lower this to say 0.1 and you can clearly see our geometry again. Okay, so very low voxel size means very high voxel density, high resolution, and we can see our original objects here. Okay, so what we can do at this point is we can use these Boolean commands. So you can see there's this null object. The null object, remember, has all of these extrude objects underneath it as well. So that includes all of our little triangles here. So what we want to do is we want to, instead of unioning and joining this with the objects underneath those two cubes, we don't want to combine those objects together. We actually want to subtract the arrow in everything in the arrow hierarchy in that arrow null, and we need to subtract it from those two cubes underneath. So this is going to work exactly like layers in Photoshop where the top layers can be subtracted from the bottom. So I'll use subtract and boom, we just created a little hole in those cubes that are underneath the arrow. And the great thing about this is this is all procedural. So I can select this arrow null, make sure I'm in my object mode here, and I can move this up or down. You can see I can adjust how deep those arrow indents are. Okay, so super cool. And what you're gonna notice, let me hit the render button here. You're gonna see that the voxels don't render. Okay, you can't render any voxels, just like you can't actually render empty shape layers. Okay, so what we can do with the volume builder in these voxels is turn them into a mesh using that volume mesher. So let's do that really quick. What I'm gonna do is go to volume mesher, and I'm gonna place the volume builder as a child of the volume mesher. And if I go to render this now, voila, we actually have some geometry being generated here. If I go to display garage shading with lines, or NB, you can see that this is a pretty dense mesh we have going on here, but we have a mesh nonetheless. Again, this is something that would have taken a lot of effort to try to model this the traditional way with getting our edge loops and polygon flows looking good. But using the volume builder, volume mesher, it really is such a great tool to make modeling accessible. So at this point, we can do a few things. Number one, we can actually smooth things out by using a smooth modifier. It's almost like a Gaussian blur for voxels. And so right in this menu here, you can see we have smooth, dilate, and erode, and close and open. So let's just see what smooth does. And you can see that I can basically just adjust this, and you can even see that there's a Gaussian operator. So this is, again, just like a Gaussian blur for voxels. And what this does is just smoothing everything out. Let's hit N and then A to go get rid of our shading with lines. You can see the voxel distance. If we lower this, it's kind of bring down the blur. If I bring this up, you can see that's going to spread the blur further. So sometimes a little bit goes a long way. So objects like this FDF smooth and all these options under here, you can basically think of them as Photoshop adjustments layers. It's going to affect everything underneath it. So if I move this below the arrow, you can see it's not going to smooth that arrow, but the cubes underneath. And I can turn this on or off to see that effect active or inactive. So that's the SDF smooth. Let's go and see what this dilate and erode does. You can see we have a fairly large offset here. If I just bring this down to say 1, you can see that it's basically just kind of expanding out the voxels. If I go to 0.5, you can see that a little bit better. I can actually go to negative as well to even erode some of this. So that was -5. Let's do -0.5. You can see it's kind of eating away. If I hold the Alt or Option key and click and drag, you can see we're eroding this away, or we are dilating the mesh there. So very aptly named. So I'll delete that. Let's see what the close and open does. Again, this is a very high value. Let's do 0.5, and you can kind of see what's going on here. So if we lower this, it's kind of gonna like remove some of the holes and the gaps and stuff like that. So you can see it's just kind of smoothing everything out. So again, I'm just gonna go and delete that because at this point I only need that smooth, okay? And this is looking pretty nice. Now, if I hit N and then B again, we have a high density. So one thing I can do is go to the volume mesher, and there's this very important adaptive slider here. And what this allows you to do is kind of remove and kind of create a threshold of removing any polygons that are on flat surfaces. So like all these polygons here on the surface, we really don't need because it's a flat edge. So if I bring this adaptive to say 0.5, you can see that it is adaptively removing polygons where they really aren't needed. So this is a flat surface, and it's going to remove some of that polygon density where the added information is just overkill, but it's still going to adaptively keep more polygons where there are edges or where there's more detail. So you can see there's a lot more polygon information on these edges where you need it, okay? So you can see the difference between 0 and 0.5. Again, just a small number, just 0.5%. is really helpful. If you crank this up too much, you really start to lose all that geometry. So 0.5 is good, and this is looking nice. So if I hit N and then A to go back to garage shading with outlines, I can maybe, let's subtract a sphere to make a little indent there, because sometimes the directional pads, they have like a little dimple right here in the center. So for that, let's go and let's just create a sphere. Let's hit T for scale, scale this down. It's very big. And we're just going to move this up, okay? And let's add this to our volume builder. So I'm going to add that to the list. You can see in the volume builder that is now updated. Let's place the sphere underneath the smooth so it's smoothed out as well. And what we're going to do instead of union is do subtract. And you can see that we just subtracted the sphere from the rest of the mesh underneath, but you can see it's pretty chunky. And the reason for that is if I turn off the volume builder and hit N and then B, you're just seeing the low polygon density show up in the volume builder. So to fix that, we can either, if I hit N and then A again, see that kind of chunkiness there. What I can do is up the segments and smooth everything out, which is nice. But if I go and reset that back to 16, each object, depending on what the object is, especially primitive objects, splines, spheres especially, have specific kind of properties once you place them in the volume builder. So if you go to the cube, you can see the options, pretty generic. But if you go to the sphere, you can see there's this option for perfect primitive. And it's very similar to the render perfect here, where what's going to happen is even if it's a low poly sphere, if we have render perfect on, it's going to render perfectly spherical and smooth. And so we can take advantage of that in the volume builder by turning on perfect primitive. Voila, this is nice and smooth, and we didn't have to actually up the segments here at all. So again, this is super nice because this is all procedural, and I can adjust the size here like so. You can get that nice little dimple. So this is looking good. What if we wanted to say kind of curve it in? Because sometimes a directional pad will either curve out or curve in. So what we can do is, if we're happy with how this looks, we actually just bake this geometry down so it's no longer a bunch of generators and primitive objects. We can do that by right-clicking on that volume mesher that's actually generating the geometry and going down to current state to object. And what this is going to do is it's going to bake everything down into its own object. You can see that right there. So at this point, we can kind of go collapse this, hold the Control or Command and Alt option, and double click to turn off all of the stoplights of everything in the hierarchy there. And let's just rename this D-pad, like so. And so now we just have this. Everything else is hidden from our viewport view and our render view because the top stoplight and the bottom stoplight are off. And so what we can do at this point is add an FFD. So we've used an FFD before. We're going to hold the Shift key down with the D-pad selected to make that a child of the directional pad. So what we can do at this point is go into point mode. And what this FFD is going to allow us to do is select both these points. And I can bring this either up or down to make a little bit of an indent. And that's looking pretty awesome. So you can see how we can really, like magic, model very complex objects very, very easily. So let me show another example to you. So here we have the bottom of that like old vintage PC, okay? And if we wanted to model like that little indent here, you can see I actually have a rectangle that's creating that. And then I have like a little disk drive bit that are just a couple cubes. And then I have like these little vents on the side. And we're going to do the same kind of thing. We're going to place all these objects in a volume builder, volume mesher, do some booleans, and make something that's a little bit more complex. So let's go and grab our volume builder, volume mesher. And what I'm going to do is just click and drag all these objects in the volume builder. Now again, voxels are very huge, so I'm going to go and bring the voxel size to 0.1. And you can see something weird happening. And all these spheres are appearing because of this rectangle. So remember, just like the sphere had that render perfect option, if you put a spline into a volume builder, it has its own options as well. We can actually create little spheres along the spline to create little voxels there. So the sphere radius is super huge. So I'm going to bring this down to say 1. You can see that we have like all these tiny spheres. We can go to like 0.5. You can see that the density along the path here, here's the path, see right here, there's our spline. You can see that there's just like some spheres being cloned onto that spline there. And if I go to the volume builder again, click on the rectangle, you can see that the density is pretty low. If I up this to say 1, you can see we have a lot more density. If I bring this to say 5, we have enough of these little spheres cloned along the spline to basically generate like a nice sweep. Now we could have totally swept that rectangle with a circle spline and placed that sweep in this volume builder, but we actually don't even need to do that because we can generate these little spherical voxels just by putting the spline in there. And so at this point, maybe we bring down the radius to 0.2, make it a little skinnier, maybe that's 0.3, and then just subtract. And we got that little edge there that we modeled in before. And now you can see this is pretty chunky, the monitor bottom subdivision surface. And so again, this is just kind of creating, if I turn these volume builder, volume mesher off, you can see that you're seeing just the resulting polygons, and they're pretty chunky from that subdivision surface. So that's just generated right there. And so if we want to, say, get rid of those little chunky bits there, we can go and up the subdivision to 4 and 4. And what that's going to do is generate a lot more polygon density. And this will allow us to have a much smoother mesh once we put everything in the volume mesher volume builder, okay? So we can again go to the volume builder, add a smooth, and maybe bring this down a little bit. And what we need to do at this point is we subtracted the rectangle to get that nice little indent there. What we can do is the vents on this side, we're just going to go and subtract that from our monitor bottom there. And again, we can adjust this to adjust the depth, just moving those vents, which is again just a bunch of cubes in a null, just move those in and out. And then what we can do at this point is go to our disk drive here in the volume builder. There's our disk drive. Go and subtract this as well. And then we have modeled this really nice disk drive hole in our monitor bottom here. I guess this is like the CPU part of our model. So again, we can go and you can see this is pretty dense, NB. We can go and bring this adaptive up to 0.5, then hit NA, and we can see, yeah, this looks pretty good. We can adjust this to maybe get rid of the little weird artifacts we have going on here. So maybe 3. See, that got rid of the artifacting. And there's one other thing that might be handy for you. I think it works much better with organic models than hard surface models like we have here. And that is the remesher. So you can see NB kind of, chaotic mesh. Usually you want to model something that has nice, even polygon flow and stuff like that. And we can do that by throwing this volume mesher inside something that is called a remesher. So it's in the subdivision surface generator menu here. So we can go and there's our remesh. We'll place the volume mesher in the remesher. And what this is going to do is use the Z remesher from ZBrush. ZBrush is a industry standard sculpting, 3D sculpting software. Highly recommend you learn it at some point in your career, 3D career, especially if you want to get into modeling and sculpting stuff. But you can see that by throwing this in the remesher, we have a very nice, evenly subdivided polygon flow. So it basically just regenerated our mesh with nicer topology here. So topology is basically like how nice is the surface of the underlying polygons of our mesh. You can see what it was before, kind of janky. We got a nice topology here with the Z remesher. Now, what you can do at this point is adjust the mesh density. So just as we were adjusting the mesh density using the adaptive, we can go one step further and be like, you know what? Let's actually cut our mesh density from 100% of what it is now, go down to 50%. And what that's going to do is remesh everything and use 50% of the mesh density from what it started from. So you can see this is calculating the bottom left here. Sometimes it takes some time, especially if you lower this a lot. And you can see that we have 50% less polygons than we had before. But again, the problem with using the Z remesher for this instance is we're losing all that edge fidelity here. Things are looking pretty rounded and kind of janky there. So I highly recommend you use the remesher with more organic forms versus hard surface stuff. But I just want you to know that it's there because the remesher is very, 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 very powerful. And this whole combination of volume mesher, volume builder is extremely, extremely powerful. It is mind-blowing that I had to kind of model the hard way, and that was the only option I had before this whole workflow came out. And so I've got you through understanding some of the basic modeling concepts through the last kind of couple lessons here. All that knowledge is very applicable because you can only get so far using this method. And if you needed to, say, adjust certain polygons or sculpt in certain details, you know how to do that. And at the very least, you know how to now take all that knowledge, understand the concepts, and if you never need to use them again in the future, that's great. And if you only use the volume mesher, volume builder workflow, that's great as well. But it's very helpful to have at least some understanding of basic modeling, traditional modeling concepts like extruding and beveling and all that kind of stuff. Because again, this is only getting you so far, but it can take you very, very far. And again, I know some people that this is the only type of modeling that they do, so do not feel self-conscious about it. Don't feel bad that you're not a great traditional modeler. I'm certainly not, and I've been using Cinema 4D for over 10 years now. Any way that you can get a model looking good, looking the way you want, is great, because at the end of the day, the client's never going to see this. It's never going to see the topology. They're not going to care about what the topology is. All they care is the end result. How does it look when it's rendered? So please, please don't feel frustrated. Use the remesher, use the volume builder, volume mesher workflow that I'm covering in this video. Don't feel bad about it. Don't feel self-conscious about it. I actually expect you to do a lot of your assignment using some of this workflow. Again, with using some traditional workflows as well. But this is super powerful. It's at your disposal. Use it, and can't wait to see what you come up with. See you in the next video.